Hi, so this is experiment number 3, the construction and testing of a colorimeter for quantitative analysis. What we're actually do is we're going to build a homemade colorimeter and we're going to compare the results from that system by analysing its LOD and LOQ to a commercial spectrophotometer. Okay, I'll show you how to use the software for this, and I'll also show you how to actually build the actual colorimeter itself. What you will find on the sheet in front of you is a step-by-step procedure for the preparation of your standards using metal orange made up in sodium hydroxide. So follow that method, make up your standards, and once you've got them done, then go on ahead and start analysing them on both instruments. And the best thing to do is analyse them on the little small guy first and then on the commercial system. So you'll end up with two calibration plots, one for the homemade system and one for the commercial system. So I'll show you that now, and actually how to build this little system and then how to use the software in the commercial system. Okay, so follow that through. Right, so when you come up to your station, what you'll find is this optical breadboard. It's made by Tor Labs, and it's a rigid piece of metal that we can mount our optical components onto. And when you're building spectrometers, rigidity is really, really important. So what we're actually going to do is we're going to take this 3D printed plastic profile. It has a bit of a Lego appearance. You can see these little nibs sitting on the top of them. And what we're going to do is we're actually going to just mount them onto the optical breadboard using a M6 Allen key, the one that you'll see here, the red handled one. Okay, so basically you'll find a bag with these little bolts in it. Screw that down nice and tight onto it. Don't over tighten because it is 3D printed. But this allows us to then just plug and play with the system. It makes it nice and quick and simple. As we go further along in the course, our builds are going to be a little bit more complicated. It will take a little bit more practicing and effort to get them right, but this is straightforward and simple. So mount this on here, I'll come back to that in a second, and we'll end up with the plate screwed down into position. It's nice and solid, and we're ready to go. And we'll just finish off that last one down here in the corner, and we could put one here, but there's no real need. Okay, so it's nice and secure. All right, first thing we're going to do is put in my detector. Okay, when you pick up these guys here, what you'll actually find is on these cubes, these are adapted from the UC2 open source firmware stuff that's available on the internet. So you can print your own. I kind of adapted these in Fusion 360 and made my own version of them. But basically what they've got is a little hole in here which aligns up with the pins on this. So this one here is for your cuvette, and your cuvette just basically sits into that hole. So what I'm going to do is I'm just going to plug in my detector first. My detector is just a silicon photodiode. It's got a BNC connector on the end of it, and we're actually going to plug in this adapter into that. So that's actually going to plug into there at the very, very end. But I'll just get that in first. There we go. I've put a bit of blue tack on it because it was kind of slipping a bit. The next thing I'm going to place in is my cuvette. The next thing I'm going to place in is my filter. A colorimeter uses a filter, okay, to isolate a particular band of wavelengths of light. It's not a single wavelength. There's actually a range of wavelengths here. And that's actually one of the things that limits the sensitivity of these systems, okay? Because if it was just a narrow band of material, you'd get a higher sensitivity. This one here, the band edge is about 20-30 nanometers, so it's quite large. But we're going to place the filter in. Just get the holes right again. Make sure that all the cages are well pushed down, so they should be nice and snug. They shouldn't be moving. The last thing I'm going to plug in is my light source. And my light source is just connected up to a USB that you would charge your phone with. It's plugged into the wall and turn it on. When you do, you'll see that you get a nice bright white light. And there's a little rocker switch here. We can turn it on and off. So again, line up the holes, push it down, and it should all sit nice and comfortably. Okay. Next thing to do is to place the covers over each of the sections. The cover for the cuvette holder is a little bit different. It's got a kind of protrusion here to allow you to put the cuvette in there. The cuvettes that we're going to use are the same ones that we're going to use on the commercial system. Okay, so these are quartz And now we don't need to use quartz, we could have used plastic, we could have used glass, but we just happen to have these beside the instrument, so why not use them, okay? So I basically place my sample in here, and I'll place the lid on top, like so. And make sure that all the covers are nice and tight to reduce the amount of stray light that may come in. The last thing we want to do is take this connector here, that's connected up to my multimeter, and just push it in and twist it so it locks in place. Okay. Then what you've got over here is your multimeter. So rotate the dial until you see a value of, excuse me, to the second one. So put it onto the 2000 M position, okay? And you'll see a number here, a voltage of 512 millivolts or 0.512 volts, okay? So that's the voltage associated with just the light source itself. When I place a sample in here, that voltage will decrease. And there's an equation on the sheet that I'm giving to you that allows you to calculate the percent transmittance, okay, and then convert it into the equivalent absorbance. Now, absorbance doesn't have a unit, and it's important that you remember that. On that sheet, basically, you'll see the schematic diagram of the instrument that I've just built. We're going to test this instrument. We're going to compare it to the commercial system, okay? And what we're hoping to do is measure the LODs and the LOQs, the limit of detection and the limit of quantification, okay? The commercial system should be much better, but what you will find is that this isn't bad, okay? Now, we'll measure the same standards on both systems, and we'll measure the same sample in duplicate on both systems. So we have a direct comparison between the two. So that's it. When you want to run a sample, take the lid off, put your liquid in here, pop it in, put the lid back on, take a reading, okay? It's important to always record the background signal first. You cannot convert the measured values, the voltages that you're getting, into an absorbent if you haven't got a measured background signal. So it's important to do that. So what I'll do now is I'll turn it off and I'll take it all apart. When you're finished, disassemble the instrument and make sure you turn off the multimeter so it's in the off position up here. The batteries will die. Again, unscrew all the little bolts and leave it ready for the next group coming in. Whatever samples you've had in your cuvettes, give them a rinse. And it's important to remember when you're doing a calibration, always start with the lowest concentration first and work your way up. Okay, it avoids contamination. So, last one. There we go. Put the little bolts back into the plastic bag that's been given to you so they don't fall everywhere, and they have a habit of doing that. So just throw them back into this little bag here, and that'll be you done for that. Okay, so I mentioned that you're going to be using a commercial system as well, and it's this guy here. It's a Shimadzu UV 1900i system. This is very similar to what you will find in industry. It's only got a 1 nanometer resolution, and that's typical in industry. They tend not to be caring about too much about changing step size. So this is fixed at 1 nanometer, but that's perfectly fine for most pharmaceutical sectors. I'm going to show you how to use the instrument now. So you lift the cover up. When you come in, the instrument will be switched on and the software will be on. But it's not that complicated to figure it out. There's a button at the side and you start the PC and double click on the software icon. It is important that you connect the instrument. So you click a button up here on the software that says connect. Okay, so the instrument needs to be connected. You also need to make sure that on this display over here, you can actually see the icon now, but this should be all ready for you. If it's not, give me a shout and I'll set it up for you. Okay, so assuming everything is ready for you to start, and I love assumptions, I'll show you how to use the software. The first thing that we're going to do is click on, you should see this screen appear in front of you. Click on this icon here. It says instrument control, and you'll see this screen here. First thing to do is click baseline. Now, when you're using a spectrometer, you generally use a baseline or an air background, or you use the cuvettes filled with your solvent that your samples are made up in. These are 1 centimeter cuvettes. The volumes is 3.5 mils. Okay, cuvettes come in different sizes. These are made of quartz, so they'll go from the ultraviolet region all the way up into the near infrared. So these have a wide spectral window which they can be used. They are fragile. Don't drop them. When you're using the cuvettes, hold them on the frosted edges, not on the clear optical surfaces. That's really important. Okay, to run a baseline, what you're basically going to do is click that button there. Okay. What I'm going to do is I'm going to place my cuvettes with the clear face pointing in this direction. Okay, so the clear face is pointing in that direction. The sample goes at the front, your reference goes at the back. So reference at the back, sample at the front. Close the lid. Once you've done your initial scan, you'll only need to change the sample. You can leave the reference one in there all the time. Okay. So when you're ready to run your sample, what you're going to do is come up to Edit. Now, this should be preset for you. I want you to scan your samples from 900 down to 370 nanometers. You always start high and work down. Data interval 2 nanometers. We're going to do high speed. That'll take about 20 seconds, and make sure it's in absorbance mode. Okay. And we're going to call this year 2 instrumentation. Okay. I'm going to save that. Give it a file name, whatever you want to call it. So I'm just going to call it test 1, right? But if you want to call it Metal Orange Standard 1, you give it your own file name, all right? And then what you do is you hit baseline. It'll ask you for the range, 900 to 370. Press OK. You'll hear the instrument scanning. And up here you'll actually see the wavelength is that. This will be quite quick. Right, so the instrument's ready. You could click auto 0 just to make sure that the baseline's at 0, but it should be fine. Sometimes you might need to do it. We generally don't. So what we're going to do now is into the back, the reference, I'm going to place some water. Okay, that's my solvent. So I'm going to do that now. Okay, so what I've got here is a solution of metal orange. I just made this up randomly. You'll have exact ones done, but I just want to show you what the absorbance spectrum looks like. I'm just going to pour in some of the orange liquid into the cuvette and place it into the spectrometer, like so. I've placed in some of the sodium hydroxide solution into the reference, and I'm just going to put that into the back as well. I'm going to close the lid, and all I'm going to do is press start on the keyboard. And all I'm going to do now is press start on the keyboard. This icon here. It says, do you want to override? Oh god, yeah, let's do that. And this will be fast. You'll see the scan coming along here, here, nothing. And about here we should see a peak. There we go. It's fairly concentrated, so I'm going to have to change this up, I think. We can close that icon so I can see the spectra, so close that. But if you want to bring it back up, you just click instrument control again. Now you can see that the peak's gone off scale. It's just because it's so concentrated. If I change that to 5, you can see it's very noisy up here, which means that that solution's too concentrated. So what I'm going to do is, just for demonstration, I'm going to dilute that down. I'm going to empty most of it out, and I'm actually going to just put water in there and then fill it up and try and run that. We'll see the same peak, but it'll be much, much lower, and we won't have this noise associated with it as well. So I'll do that now. So I've diluted that sample down quite a bit. It's still fairly intense in colour, but I'll try that again. I'll throw it in, not literally of course, and I'm just going to come on over here to the software. I'm going to click on the instrument control icon, brings it up the window. I'm not changing anything, so I just press start. If you were looking at various samples, you might need to change wavelengths, but we're okay with this. So just press, it says enter file name, so I'll call this test 2 just for the sake of it, but you can call it whatever you want and just press start. Do you want the data? Yes. And there's the second trace appearing. Now it'll appear, but it'll be much, much lower this time. There we go. Generally, you should never really go above 1.5 absorbance units on any spectrometer. Even though this is a spectrophotometer, the difference between a spectrometer and a spectrophotometer is a spectrometer is a single beam instrument. A spectrophotometer is a ratioing instrument, so it actually takes a signal at the same time, or almost at the exact same time as a reference signal has been measured. So it allows the calculation to be performed instantaneously. Okay, what I want you to do is for each of your standards, I want you to measure the height of the peak. The way to do that is on the screen, click the cursor icon up here. It says crosshairs, yeah, go with that. And then just position it to the top of where you think the top of that peak is. And looking at it, it's at about 462, 465. That wavelength will shift depending on the pH of the solution, all right? And what I want you to do is write that value there, the absorbance, the Y value. So you'll see it's at 1.558, okay? That's what I want you to plot against the concentration. So you measure that for each of your standards, and then you plot it, and then you get your calibration line. You then use the STIX, the intercept, and the slope function on Excel to calculate the limits of detection and the limits of quantification. And remember, you will have the measurements done on this instrument done in duplicate, as well as the other instruments. So the best way to do this is prepare your first set of standards, measure them on the homemade system, and once you've measured them on the homemade system, transfer it straight in here and measure it on here. Then empty it out, do the next standard on the homemade and then the commercial. And keep going like that back and forth. Do that twice so you've done it in duplicate. Okay, and once you've done duplicate analysis, measure your sample in triplicate and comment on your results. And that's all you gotta do.